So once again, welcome all of you to the second session of day 3. Now, the resource person with us we have is for the second session is Mr. Shashank C. Bangi sir. So now he is currently working as assistant professor in civil engineering department at GIT Belgaum. Now he is from 2015. He is in the teaching profession. Now he has completed his BE in civil engineering from BEC Bagalkot in the 2013 and completed MTech in remote sensing and GIS from NITK Suratkal in the year 2015. Currently, he is doing research on estimation of actual evapotranspiration by using surface energy balance based on remote sensing techniques under VTU Belgavi. His teaching and research interests include remote sensing, GIS systems, advanced surveying, water resources. He has taught various subjects at UG as well as PG level in the area of in the field of advanced surveying, RS and GIS. And he is actively involved in surveying laboratory setup and other department consultancy work in the field of surveying. He has also been invited as a resource person on many FDPs and workshops. To name few, one is advanced survey and total station theory, as well as practical, and then advanced pavement and geometric design, then on AutoCADs. So he has also conducted many workshops on surveying using total stations, that is hands-on workshop also he has organized. So he has been sponsored with under TechUp funds also. He has also been resource person for 1 week FDP on infrastructure works in survey to execution and modern project management techniques. With this brief introduction, I welcome Shashank sir to this 1 week FDP. So, sir, on behalf of again BLD, CET and AICT, we welcome you to this FDP, sir, and request you to take over the sessions.
Okay, thank you, sir. Thank you for your nice introduction. Good morning to you all. I just would like to start with my session. I hope my presentation screen is visible to you.
Yes, sir, clearly presentable.
Okay, now, good morning, everyone. Today I'm going to start the session on GPS and Dgps. So as you all know, GPS technology is not an new technology. So this is old technology only. It was started in the 1970s. Still, it is being in use, and the only advanced thing under this GPS and DGPS is the applications. So whatever we are using nowadays, along with some other technological inventions. So they are playing a very major role along with this GPS, and also along with the GPS, we have geographical information system and remote sensing technology. So combinedly, it is giving a very convenient and very real-time results. So that I would like to discuss with this presentation. So here you can see there are many applications under global positioning system. I would like to start with the applications first before starting with the working principle and different components which are present in the GPS, because you all are familiar with the many applications of GPS. So to name few, we have been using GPS in the logistics to track the vehicle movement from one place to another place. We can keep track on the vehicles, and also we can find out the time required to travel from one point to another point, and also based on the time, based on the distance, we can calculate the cost which is involved in sending the parcel from one point to another point. Not only at the logistics, the GPS is being in use under the municipals for effective waste or waste management. It may be related to the collection of the waste. So if we can collect the waste effectively with the help of shortest distance from one point to another point, so that can be treated at the required place, and that cost can be minimized with the help of this GPS technology. And rental cars are using GPS to find out the shortest distance from one point to another point, and also to find the cost involved in traveling from one point to another point. Construction industry is also using GPS to monitor the maintenance work, and also to atomize the work. For example, if we want to excavate some material from one point to another point, that work can be atomized with the help of GPS technology. So nowadays, as you all know, many people are using drones for surveying applications. For drone, for surveying purpose, we need GPS. Without GPS, we can't do any surveying, because main position is received from the GPS satellites itself. So that's why the drones are also making use of GPS, and most of the deliveries nowadays, so they are also using GPS. So some of the companies which are using this concept extensively are the Google. You all are aware about the Google Maps. Many people in day-to-day life, they are completely depend on the Google Map to travel from one point to another point. So Google is using very effectively. They have developed their own mapping platform. On top of mapping platform, they have kept this GPS. So because of that, we can find out some unknown places also. Okay, so that is one of the advantage of this GPS. So only with the help of GPS it is not possible. Along with the GPS, the digital map is also required. But one more advantage of this GPS is GPS does not require any internet connection. Internet connection is required only for the base map, but GPS does not require any internet connection, and it is free. Anyone can make use of this technology. And not only for the positioning purpose, the Google is making use of this technology for the security purpose also. You might have seen nowadays, while transferring the money from one person to another person by using Google Pay, it is asking us to turn on the location. So why it is asking us to turn on the location? It is completely giving and security for us to find out the transfer is taking place from which place to which place. So based on that, if something happens in the future, they can track down the location and they can find out. Okay, so these kind of inventions are taking place in the field of GPS. So and some of the other popular companies such as Zomato and Swiggy are also using this technology to deliver the food at assured time. Ola and Uber cabs are also using this. Facebook is also using. Every time whenever you go for some movies and some malls, so you usually tag the location. So Facebook is making use of your location, and they are making use of the location to share the data with others. Okay, the whatever the data you share, they are making money with that data, and they are sending it to the some other data analytical companies. So many, along with this, many geotagging and Android applications are available nowadays. Many applications ask you to turn on the location, even though that location is not required, but they are asking you to turn on the location. So the thing is, they are collecting your location information in the background. So like that, many applications are using this GPS technology. So with this, I just would like to start with the basic concepts of GPS. So the first thing is why positioning is required. First, you need to understand why positioning is required. So as you all know, the shape of the Earth is very complicated. It is not a complete spherical object. Some people call it as a geoid. Some people call it as a spheroid. So the mean surface of the Earth is spherical in nature, but Earth is having lot of undulations on its surface. It is very difficult to find the location of the required point on the surface of the Earth. So even while doing the survey, we need at least three main components, that is distance, direction, and elevation. Without distance, direction, and elevation, we can't locate the position. So that's why it is very important to get the location with the help of some remote sensing concept. So in this GPS technology, the remote sensing concept is incorporated to find the location in X, Y, and Z direction. So that is the requirement. So as we see in the previous days, a man started locating his position with the help of some materials which are present on the earth. During Stone Age, man used to mark on the stone and trees which are present nearby, and he used to come back by making use of that markings. And eventually, he has started exploring the astronomical objects such as stars, and with the help of stars also we can find out our location. So next, in the radio age, man started locating the position with the help of radio waves. And later, nowadays, we are making use of satellites as well as radio waves to find out our location very easily. So these are all some of the techniques what we have used as of now. So with this, I just would like to start the actual concept of GPS from this slide. So coming to the introduction, GPS stands for Global Positioning System. It means the long form of GPS is a Global Positioning System. So it provides positioning, navigation, and time services. It means GPS not only give us the location, along with the location, it can give us a precise timing at the location of the receiver. GPS is a satellite-based navigation system made up of a network of 24 satellites placed into an orbit by US Department of Defense. GPS was developed by US Department of Defense. It was developed basically for the military purpose, and later it was made available to the public in 1980s. In 1978, they have developed it for military applications only, and it was developed only for the military applications. And later, with the discussion, with government, they have made it available to the publics also. And GPS works in any weather condition, anywhere in the world, 24 hours a day. It is not like that you can use it only in the day, or you can use it only in the night. You can use it anytime, but only thing is the signal should receive at the user end. Okay, you can't use it under the roof. That is only the drawback of GPS, and it is not having any subscription fees. You can use it at free of cost. Nowadays, everyone is having GPS in their mobile. They can make use of the technology, and they can make use of the GPS, and they can find out their location at that too at free of cost. Only at the initial, while purchasing the cell phone, you need to pay for that. and after that you can use it anytime without giving any subscription fees. So that is one of the advantage of this GPS. Actually, the global positioning system, originally it was called as a Navastar. The meaning of Navstar is a navigation system using time and ranging, because it is completely based on the measurement of time as well as ranging. So that's why it was called as Navstar GPS. Now all are calling it as only GPS. It is a satellite-based radio navigation system. It is one of the global navigation satellite system. Actually, the GPS is a part of global navigation satellite system, but many people are calling GNSS is also GPS. Okay, it is not like that. Actually, there is a global navigation satellite system throughout the world. So under that, GPS will come. But as GPS was developed first by the US military force, so that's why from that day people are calling it as GPS only, but it is actually a navigation based satellite system. The GPS project was started by the US Department of Defense in the 1973 itself, with the first prototype spacecraft launched in 1978 and a full constellation of 24 satellite operation in 1993. So it means the major operation was started from 1993 with full constellation of 24 satellites. So with this introduction, I would like to start with the working principle of GPS. So many people are using the GPS, and many people knows about the applications of GPS, because many people are using it day by day for their work. But many people don't know how it works, how it calculate the distance, how it calculate X, Y, Z position. So as we think it in the surveying perspective, so to get any one point with respect to some other reference, we need distance, direction, and elevation. Many components we need, and also along with that, we need some instrument is giving that kind of service to each and everyone. Just imagine how many people are using GPS at a time, and how the GPS every people on this world. So just imagine. So this is possible only because of the electromagnetic radiation which is involved in the technology. So that I'm going to explain in this presentation. Coming to the segments of GPS, before going to the core principle of working principle of GPS, I would like to explain the components which are present under the global positioning system. When it comes to the segments, or you can call it as a components, there are three segments of GPS are there, because what we can as a common people or a common person, what we can see under the GPS, we can see only the receiver, GPS receiver, and some of the people might be knowing it works on the principle of electromagnetic radiation, and some people may think like it is working only with the help of satellite and receiver. No. So along with the satellite receiver, we need control segments also. So like that, the whole process is divided into three segments. The one is space segment, other one is control segment, and last one is user segment. So only with the help of all this segment, the process will be completed. Otherwise, this process will not be completed. So I just would like to explain one by one. So the first thing is the space segment. Space segment involves satellite which are orbiting around the Earth. Satellites are placed at an altitude of 20,200 kilometers away from the Earth. It means the kilometer. Means they are present 20,200 kilometer away from the Earth and they are orbiting around the Earth. Total under this GPS, each orbits are having 4 satellites. The satellites are placed in such a way that the signal can reach each and every segment. In control segment consists of master station and monitor stations. The master station is present in the US. So that master station, the use of that master station is to control the space segment as well as monitor stations. And this control segment is also having monitor stations and they are placed around the Earth very near to the equator. So monitor station collect the information from the satellites and they send it to the master station where they check the working of the GPS satellites, whether the time is correct or not, whether they are sending the signals properly or not, and the performance and their battery performance and everything they will check. And if any errors, again the master station will send the corrections to the monitor station and then monitor station send the information to the satellite and it will be corrected automatically. So continuously the whole system is monitored by using this monitor station and master station. So you can see the location of the monitor station, ground antennas and master control station on this screen. So this is the globe and it shows you the location of the master control station. Here you can see a US Space Command. In US Space Command, you can see the location of the master control station and also the monitoring stations are kept around the Earth very near to the equator. You can see it very clearly. And also these monitor stations are placed in very isolated regions. You can see the location. They are intentionally kept at the isolated locations so that there should not be any interruption from the others. So their job is only to collect the information from the satellite and send it to the master station and get the correction from the master station, and all the monitor stations receive the information from the command center and then finally send it to the satellites. So these are the some of the jobs done by this monitor stations, and these monitor stations are distributed throughout the Earth in such a way that they can connect to each and every satellite. Because sometimes what happens, this this control station can connect with only few satellites, say 10 numbers, and other satellites will be behind this monitor station. That time this can connect with other 10 satellites. So like that, these monitoring stations are placed over the globe. So as I explained, space segment consists of the satellite, control segment consists of master station and monitor station. Along with that, one more segment is there, that is user segment. So this you all are familiar with this user segment because user segment consists of GPS receiver. So whatever the receiver we are using, the best example for that user segment is the cell phone. We are using cell phone. In our cell phone, the GPS receiver is there that receives the signal from the satellite and that will find out the location, our current location. So everything is automated. So these all are the different kind of segments available under GPS. Okay. And here also you can see the animated picture of the working principle of GPS. So how it sends the signal and how it is monitored. So here you can see the satellites which are orbiting around the Earth and control segment is collecting the information of the satellite, and also it is sending the information to the satellite, and user segment is getting the information from the satellite. Okay, there is no connection between the control segment and the user segment. The user segment will get the information only from the satellite. But the thing is, many people might be having the question in your mind, like how it find the location. Okay, that I'm going to explain it in the next slide. That is the very important part of the global positioning system. The first thing what I would like to explain is how it measures the distance. Because as you all know, to locate any point on the earth, we need a distance. But how GPS can calculate the distance from one point to another point? Okay, so that is very easy. That is completely based on the principle of electromagnetic radiation. So as you all know, the simple formula of speed is equal to distance divided by time. This is a very basic formula for calculation of speed. But thing is, here we need distance. So if we want to calculate the value of distance, it needs speed as well as time. In order to calculate the distance, we need speed and time. And out of the speed and time, the speed is a known quantity because all electromagnetic radiation travel with the speed of light. So the speed of light is known quantity. So only unknown quantity is the time. If we can measure the time required to travel, then we can calculate the distance between one point to another point. Even the total station, that EDM which is present in the total station, measure the distance using same principle. The laser will emit from the device, so it will hit the target and it will come back. Will travel the laser from one point to another point. Based on the time and based on the speed, it calculates the distance. Same concept is being used. That's why they are not using laser. They are using radio waves because laser won't travel too much distance. As I said, that's so that's why radio waves are being in use under the GPS technology so that they can travel for a long distance. So, and also it can carry the information about the position of the satellite and time information. So what happens? The receiver receive the signal from the satellite, and satellite send the information about the position of the satellite as well as the time. Receiver receive the information from the other satellites also. It compares the time and finally calculate the time required to travel the waves from satellite to receiver. Based on the time, receiver can calculate the distance of satellite from the position. Okay, so if we can calculate the distances from different satellites, the location of the object can be calculated. So the simple trick is it uses trilateration concept. In surveying, two concepts are very popular. One is triangulation and another one is trilateration. So in trilateration, what happens? We make use of only distances to find out the unknown location. In triangulation, we make use of one distance and two angles to calculate the distance of the unknown point. So this is the only difference. So that I would like to explain with the help of this diagram. Here you can see, imagine you are standing on the earth and receiver is receiving the signal from one satellite. So here there is an example of one satellite. Satellite is sending an information and receiver is receiving. So once the receiver receive the information from the satellite, the receiver will get to know where is the location of satellite, but it will not get to know the direction of the satellite. Because if we want to locate any place, along with the distance, direction is also required. Distance is not enough. For example, if I tell you where is or if I ask you where is Vijaypur from Belgaum, so you may tell like Bijapur is around 200 kilometer from Belgaum. But 200 kilometer is okay. But in which direction? It is 200 kilometer. Whether we have to move towards the north, south, east. That's why only distance is not an enough. Direction is also required. Or else different distances are required from different places. Then only we can reach the destination. So here the same concept is being utilized. I can show you the one more example. This is the one example where receiver is receiving the signal from one satellite. Next, you can see the receiver, the same receiver is receiving the signal from the second satellite. So now, with the help of two satellites, the location of the satellite or location of the receiver is optimized to some particular area. Now, at least with the help of this two circle imaginary spheres, I can tell that the receiver is somewhere present in this region because the two spheres are overlapping, right? So where they are overlapping, somewhere here they are overlapping, and I can predict that the location of the receiver is somewhere present over here. And next, even two satellites are not enough to find out the actual location of the receiver. So we can make use of the third satellite. So if you look at the figure, you can see there are 2 points where all the 4 circles are coincided. One point is on the earth and another point is away from the earth. So this point will be neglected and this point will be considered. So based on this, we can locate the location of the receiver. But not only 3 satellites, along with this 3 satellite, one more satellite is required for cross-checking the location and also to check the time, because here there are 4 unknowns are there. It is a kind of equation where 4 unknowns will be there, and to solve that 4 equations are required, right? So here here is also same. What are the unknowns? X, Y and Z, or else you can say latitude, longitude and elevation along with this time information. So to find out the unknown of all these 4 things, we need 4 equations that can be developed through the 4 satellites. So this is how it locate the position of the receiver. So these are the some of the examples how GPS calculate the position on the earth. Here you can see that here also you can see the 3 satellites which are creating an imaginary sphere around it, and where they are going to intersect, that particular point is the receiver's location. So like this, n number of receivers can work on the same environment and it can calculate, because the main job of the satellite is only to send the information. So receivers simply receive the information and calculate the location. So this is how the working of GPS is going on. Here you can see one more example how the location of the particular receiver is calculated based on the satellite position. Here you can see this concept is known as trilateration, because this distance is known, this distance is known, and this distance is known. If the 3 distances are known from the known location, because satellite will be knowing its own location, they are placed in such a way that every second they will be knowing their location. So while sending the information, they send their location also. Along with that location, they send the time. So based on that only, the position will be calculated. So this is how the position is calculated. And here also you can see the animated figure, how the receiver receive the signal from many satellites which are available on the earth. You can see the satellites are placed in such a way that receiver should receive the signal from at least 4 satellites. Okay, while using the GPS receiver, always you have to check whether the receiver is receiving the signal from at least 4 satellites or not. If the receiver is not receiving the signal from at least 4 satellites, then definitely it will give you a wrong location. So before taking the location, you have to check that whether the receiver is receiving the signal from at least 4 satellites or not. Okay, so nowadays, along with the GPS, many other navigation satellite systems are available, and receiver can receive signals from more than 30 satellites. So that's why the accuracy generated by the GPS receiver will be more. So here you can I can show you one more example of trilateration concept. Trilateration concept. Here you can see we can locate the position of the cell phone with the help of towers. As you all know, towers also use the radio waves. So here you will get to know how the location of cell phone can be located with the help of tower signals. So once the cell phone receives the signal from the tower, this tower can calculate the distance between tower and cell phone. But for this particular tower, only the distance between tower and cell phone will be known, but actual location of cell phone is not possible to find out, only with the help of one tower. Okay, so it can imagine the cell phone is present somewhere on this circle. So once the cell phone receives the signal from another nearby tower, so that time we can say that the cell phone is present somewhere in this area, because these two circles are coincided. So this is the same concept what other people are using to find out the cell phone. And when the cell phone receives the signal from third tower, so that time we can find out the accurate location of the cell. So this is only the two-dimensional idea. Actually, three-dimensional idea is incorporated in the GPS. There, the sphere will, imaginary sphere will be created around the satellite, and here only circles are provided. Part radio waves, and here also you can see the GPS satellites. As I told, 24 satellites are orbiting around the Earth, plus on the Earth, they are kept for emergency purpose. If one satellite is not working, then the same function will be shifted to the another satellite. And total 6 orbital planes are there. It means the satellites are rotating in 6 orbital planes, and each orbit is having 4 satellites. So 4 into 6, it is 24, total 24 number of satellites. And the satellites are placed on the orbit in such a way that every signal on the every receiver on the Earth should receive the signal from at least 4 satellites. So that is the main concept which is used in this concept. Coming to the very important part of this presentation, I just would like to highlight